Welcome. It has been a long time since I did a YouTube video. I guess I tend to neglect this channel for some reason. It's not my intention, but creating videos is a little bit cumbersome. However, I think it's a perfect excuse to come back to talk about the current statistical arbitrage system that we use in the gamma optimizer room. Now, so this video, the goal of this video is that it serves as a manual, no, a complement to the written manual, if you wish, for the ultra constant stable trade, which is the one that we're using right now. Okay, so it is a statistical arbitrage system anyway, no? Why do we use that, no? In particular, in a room that tends to trade options. So in the gamma optimizer room, even though it's an option-oriented room, we tend to stay, or I tend to shy away from the wild bets. No, I don't do zero DTE, or I usually don't bet on big directional moves on an underlying like the S&P 500 or Tesla or Nvidia or Apple. No, so I don't change momentum. I guess that's a way to put it. For the last several years, what I like to do is I like to trade volatility. No, and trading volatility is very interesting. Trading volatility implies that it's easier to forecast volatility than to forecast price, which is the truth. No, that's usually the case. No, so for instance, my main focus is the S&P 500, the 500, the index, no, SPX, as you might know it. So my focus is SPX because it's a well-diversified index. Also, it's kind of a self-fulfilling prophecy. It is every year the index changes a little bit based on market capitalization. So it stays strong year after year. And the other thing I like is that volatility, even in the worst of the times, tends to be a little bit more subdued than volatility on like something like Nvidia, or volatility in Tesla, or volatility in some of those really high beta names that you guys are used to trade now. So I like something a little bit on the calmer side, more calm, a little bit more subdued. And it also lends itself for better forecasting techniques. So the current system that we use is called a statistical arbitrage, in the sense that we don't want to win every single trade. No, that's not the goal of the system. It's impossible to win every single trade. But the thing is, we want to keep a positive edge on the trades. No, so we are going to win a certain percentage of trades, probably 55, 60%, sometimes 70, who knows. But the idea is that the winners, the profit from the winners offset the losses now, and you get to keep a little bit of it when you do long enough period of trades. Then you discover the edge starts to materialize. No, that's kind of how I see the systems. So in that sense, statistical arbitrage is that, no, just playing the long game. Is not doing one trade and winning one trade. No, it's doing like 20, 40, in our case, 250 trades. Now we are doing a whole year of trades. And the idea is to extract some edge from each of them. So currently, my goal is to extract at least from 20 cents and up from each dollar invested on the trade. Now that's kind of what I what I want to do. So for that, I present to you ultra constant stable. So why does ultra constant stable do? Well, it is a system that seeks to predict the returns of the S&P 500 for next day. But instead of trying to predict if the market is going up or is going down, the system tries to predict an amount of return, or some kind of 1% move, or 2% move, or 0.5% move. And we don't care about the direction. No, that's how the system works. Now, it's a system that is pure based on statistically based on returns, and we don't care about any direction. So what are the specific details of constant and stable? Well, there are infinite ways of playing volatility, but the gist of what we want to do is the following. The market tomorrow, for instance, tomorrow is closed. I am recording this just before Thanksgiving. But on Friday, the market will close at some distance from the current close today, So the market will either be 0.5% up or 0.5% down. The thing is, we don't know in what direction it will go, and I don't care. I really don't care what direction it will go. So the idea is to, okay, let's have some kind of mathematical framework and come up with some kind of confidence interval, some kind of confidence interval where we can say, maybe the market is going to be between this and this return. Maybe the market is going to be between minus 0.6 to plus 0.6, or between minus 1% to plus 1%, some kind of range, And we can pick, there are infinite ranges. Now you can pick whatever range you want, and you come up with that system. And then what you do is see what option dealers are doing, So they are also pricing options. They price options, but by a trick of option pricing, we can more or less see what kind of odds they have been assigned to certain levels. No, so what I want to say is that from option prices, we can also compute the same intervals. It is something that can be done. There is plenty of literature about how it's done. You usually take the second derivative of price versus the strike, and you create some kind of final distribution, some kind of PDF probability distribution function based on those derivatives of prices. It's a little bit complex, but it's not too hard. It's not that hard to do. So then you have two different probabilities. Now you have one probability distribution that you compute yourself with your own system, and you have one from the dealers. No, two. And if the universe is perfect and the information in the market will be perfect and ideal, then the two probabilities should match completely. No, there should be no mismatches. But the truth is, dealers don't care about what happens in the real world. Dealers, when they price options, they are not working on the same probabilistic space that we are working. So in a more technical manner, option dealers, the people that actually provide the options that we buy, they work on a risk neutral probabilistic world. So in that world, they don't care about the drift in prices because it's hedged away. So directional risk is hedged away by them. They don't take the directional risk. So therefore, they are taking pure volatility risk, and that's how options are priced. So they come up with a kind of probabilistic distribution function that works in this risk neutral world. On the other hand, we are not hedging away our positions. We are actually depending on the true probabilistic distribution function for returns. So our two distributions will never match. I shall say most of the time they will never match. Because in one day the drift is not that much, but there are small differences that can be monetized, and that's what UltraConstantStable is doing. UltraConstantStable is seeking to monetize these small differences. So as I mentioned, you can come up with any range. You say, oh, I want to compute a confidence interval on my world and the full risk world, and compare it with the same confidence interval from prices, from option prices, from dealers that is risk neutral. And then we can compare and see that maybe this tail, the right tail of the confidence interval, is overpriced according to my system. Or the left tail is overpriced, or vice versa, it could be underpriced. And then we could come up with tons of different trades. We could sell overpriced tails and buy underpriced tails, and we can mix and match. And that's what UltraConstantStable is doing. Now, so it sounds a little complicated, but it's not that complicated. The system is presented to you, as the end users, is as a final trade. So you don't have to worry about the internals of what is going on. Suffice to say that under the hood, there is some kind of arbitrage play, a statistical arbitrage play. Of course, it's not bulletproof, no? What happens in my my forecast, the forecast that I am creating, the system that I am creating, is completely wrong. And he told me that this was overvalued, but it actually isn't. So it's not bulletproof. So don't think that I discovered some kind of holy grail. It's not about discovering holy grails. It's just trying to find misprices between both worlds, no? And so what do we use underneath? So many people, I'm not the first one to do this. This is done at many levels, at institutional level, at hedge fund level. Um, but so I think one of the few retail traders doing it now because it requires lots of computation and lots of data. But the system, how does it look like? The system is very simple. The system is just basically a neural net. I'm using machine learning, and it's funny enough. I've been using this since it became fashionable, no? Machine learning and now AI. No, there's AI this, AI that. But when I created these systems, it was back in 2012. Back in 2012, no one was talking about AI, and the correct term that we should use was machine learning. No, that's how we should address. And we were forbidden to call the system a artificial intelligence. No, and there was some stigma associated to it. So no one in the right mind will market an artificial intelligence system back in 2012 because artificial intelligence itself, the term was blacklisted. But since it was, it's not blacklisted anymore. I guess now it's mandatory, but uh, I don't like it. This is not an AI system. However, it is a machine learning system. It's a system that uses techniques from the machine learning world, in particular neural nets. So ultra constant stable at the end of the day is just a neural net. And the neural net take a bunch of inputs from the market, and those are like real, tangible inputs, observables from the market that I buy, from different data sources, and they come in real time. And it is magical in the sense that it takes all these inputs and apply all these machine learning techniques, in particular a huge neural net. And what it does internally, it comes up with a probabilistic distribution function, no? And then it compares it, it's the same nets, compare that with the pricing from options, and they then at the very, very end, at the last stage of the system, it just spits out a signal. It says, sell this tail, buy this tail. So at the end of the day, it just produces two signals, a signal for the left tail of the distribution, which it could be sell or buy, and another signal for the right side of the distribution that could be sell or buy. You know? And the intervals themselves, no? What are the intervals? There are infinite intervals, as I mentioned before, but I am looking in particular for the 60% confidence interval. That's what I'm looking for here. I'm not looking for anything else. The 60% confidence interval is very convenient because it is big interval. No, 60% of the returns should be inside and 40% should be outside of the interval. Uh, and the other thing that is convenient is that the prices of options for those intervals are still decent. I could have gone for like a 95% confidence interval where 95% of the trades should be inside the interval and I will win 95% of the time. But those systems are pointless or not pointless. Let's say they are really hard to implement with neural nets because the 5% times where the market is outside the interval are really small compared to the 95% of times where the market is inside the interval. So you are training the neural nets with very unbalanced data sets, because we have tons of examples for when the market stays in the 95% interval and just very few examples when it just breaks it, it closes outside of the interval. And neural nets, for those of you that have played with them, that kind of imbalance in the data doesn't play well with neural nets. So I prefer a 60-40. I could have gone 50-50, some members of the room asked why I didn't create a system that is 50-50, like a 50% confidence interval, half of the time inside, half of the time outside. I could have, I happen to like the 60-40 for some reason. No, I went for it many years ago and I stuck to it. Now, my first system was called the NDLA, and the NDLA was basically the 20% leg to the right tail of the interval, the right leg of the interval, which is if you have, if you imagine the distribution, you imagine the 20% to the right. Now you imagine 20% on this side. So I was playing only one particular leg of the distribution at that time, and then I Nowadays I'm playing the full distribution, the two legs, the two tails of the distribution. So that's constant stable, no? That's the interval. Interval is 60%. What else is there? The other thing that I'm playing is that I am playing a constant pricing, because there are many ways to play it. You know, when you have two probabilistic distributions, you could use your own distribution and find the 60% interval for your own personal distribution, and then compare it. The strikes at the end of the distribution, you can compare how dealers are pricing it, and if there are differences, you do, you know, buy or selling. But notice in that system, the probabilities that you compute stay constant, but the price, the cost of the trade is variable, because sometimes for those strikes, they could be very expensive from the dealers, or other times they could be very cheap. So in that system, pricing is variable all the time. You know how much it will cost the trade. You will know if tomorrow I'm going to make more money than today. So yeah, we tried that system. I tried that system, and it's not that it didn't work. It's just I didn't like the variability. I didn't like. I want a system that is more predictable, where I know how much money I have to spend up front, and I can commit capital to it. But in this system, the cost is variable because I am using my distribution and comparing it with the distribution from dealers. So the second defining characteristic of constant stable is that we are using the distribution from option dealers. That's the trick, no? They also have supercomputers. They are way smarter than I am. They have teams. I am just a single guy. So an option dealer like Citadel or Goldman Sachs, or who knows, JP Morgan or Virtu, those guys have really tricky and sophisticated software and 20 people working on it, and they come out with their own interval, and that's how they price it. Even though it's risk neutral, they are using more or less the same techniques I'm using. So then what I want to do is I use that for them. So I use the 60% interval computed from option prices. And then I compare it with my interval. No, notice that is the opposite. Instead of using my system and comparing it with the dealers, I'm using the dealer's interval first, and then compare it to my own interval, and then I buy or sell. What is the advantage of doing that? The advantage of doing that is that you get constant pricing, no? Because the intervals, the strikes are all over the place, but the price is always the same. No, if you're playing the 60% interval, it should be priced at 60%. No, for those of you that like to play that kind of price options in that kind of way, no, when you talk about binary options, then that's how you price them. So if you think about this as a binary trade, where I'm betting if the system will finish inside or outside the interval, then the binary bet would be priced at 60%. And it's constant pricing. And the same thing for playing outside is priced at 40%. So those prices are consistent. And so that's why it's called constant stable. No, it's called constant because the pricing is constant. Therefore, my capital needs are constant, and I known in advance. I know exactly the cost of the trade, and I know how much money I'm going to make on this trade, or on every trade, and I also know how much money I'm going to lose on every trade. And I like that. It's not variable, it's constant. So that's ultra constant stable. That's the constant from the from the name. So we'll move to the next part about the net, and the next part is, okay, so how do the trades look like, no? And that will be the next portion.